Hi there, Mr. Sutton here with the IM322 Part 2 homework solutions on greatest common factor. On this problem, trying to factor, we see that there are four terms, so we can try factoring this by grouping. Looking at the ratios of the terms, first off, there's no common factors I can take out of all of these, but if you look at the first two coefficients, we have a 30 to 6 ratio. Reducing by 6, that's really a 5 to 1. And then over here, 35 and 7, that's also a 5 to 1 ratio if you divide both of those by 7. So we can definitely try grouping. Let me try taking something out of the first two terms. I can take a 6 out of both of those, and also an x. So that's going to leave me with, let's see here, this is going to be 5a left over from the 30a. And then 6x divided by 6x, well, those just give me 1, so minus 1. For these next two terms, those are both divisible by a 7, and they also have a y that they can both give up. So 7y, positive. 35ay divided by 7y, that's going to leave me with a 5a. And negative 7y over 7y, that's also a minus 1. I have a 5a minus 1 in both of these now, so I can factor that whole parentheses out. And that leaves me with the leftovers from each term, which are 6x and positive 7y. To factor this one, let's first check to see if there's a common factor for all four of these terms. And it looks like there isn't. We've got a 49, a 70, a 63, a 90. There's no number that those are all divisible by. Okay, well, in that case, let's look at letters. No, they don't all have the same letter. They have some combinations of the same letters if you look at two at a time. Because there's four terms, this is a pretty good indication that grouping might work here. So let's look at the ratios of the first two and the last two coefficients. First two coefficients, 49 to 70, if you divide both of those by 7, you've got a 7 to 10 ratio there. And now the next two, we have 63 and 90. Well, if you reduce those by 9, you also have a 7 to 10 ratio with those coefficients. So let's go ahead and use grouping. Let me take out a common factor from the first two terms here. 49 and 70, both divisible by 7, and these terms also both have a y. So 7y is what I'm going to take out of those. And 49xy, if you take out a 7y, you have a 7 and an x left over. And if I divide negative 70by by 7y, that's going to become negative 10b. The y's are going to cancel there. All right, let's take some things out of the next two terms. I can take a 9 out of both of those. And they also both have an a, both of those terms, so plus 9a. 63ax divided by 9a, that leaves me with 7x. And 90ab divided by 9a, well, that's going to be a 10, and the a's cancel, so I still have a b left over, so minus 10b. And we see that we have the same thing in both parentheses, which is what we expected and hoped for. So I'm going to take out that 7x minus 10b as its own common factor. And now I'm going to put the leftovers, 7y and 9a, next to it, undistributing those into their own parentheses. For this problem, it looks like we've got four terms, so grouping is usually a good one to try on one of these. Just taking a quick look at the ratio of the first and the last two coefficients, we have a 1 to 2 ratio for the first two, and 2 over 4, that reduces to a 1 to 2 ratio. Now the signs are a little bit different, so let's start trying grouping on this and see what happens. So we've got, let's see, I can take a q out of the first two terms. That leaves me with a p minus 2. For the next two terms, all I can take out is a 2, leaving me with a p, which is a good start, and then we have a plus 2. Now, p minus 2 and p plus 2 are pretty close, but they are not the same thing. So I can't just take out a common factor with either of these parentheses. This means basically, since I don't have the same thing in parentheses and can't get it to be the same thing, that factoring by grouping is not going to work here. And that's really the only kind of factoring that would have worked at all on this one, since there's no other way to take out common factors or other techniques that'll work. So this one is not factorable. This one is prime. For this problem, trying to factor these four terms, taking a look to see if I have any common factors in the very beginning, it doesn't look like I do. I've got a 12, a 10, an 18, and a 15. Those are not all divisible by the same number. And in terms of variables, the first two terms have x's, but nothing else does. And the first and the third term have y's, but nothing else does. So we can't really take out any variables either. Because we have 4 terms, though, we can try factoring by grouping. Let's take a look at the ratios of my coefficients. The first 2 coefficients, 12 over 10, that's a ratio of 6 to 5. The next 2, we have 18 over 15. If you reduce those by 3, that's also a 6 to 5 ratio. Since they have the same ratio, I can actually go ahead and try grouping on this. So for the first 2 terms, I can take out a 2 from both of those, and also an x. They both have an x. So taking out 2x, 12xy divided by 2x leaves me with a 6y in parentheses. And then negative 10x divided by 2x, that reduces to a negative 5 in the parentheses. For these next 2 terms, those are both divisible by 3, and there's nothing else I can take out, so I'll just do a plus 3. And then in my parentheses, 18y divided by 3 is 6y. Negative 15 divided by 3 is negative 5. And happily, I notice that I have a 6y minus 5 in both parentheses. That means I can take that whole parentheses out as a common factor and put the leftovers, 2x plus 3, in a parentheses next to it. For this problem, we're trying to factor this expression. Since there are 4 terms, we look to see if we can factor by grouping. So taking a look, first off, to see if we can group it or not, we look at the ratio of the first 2 and the last 2 terms. So our first 2 terms, we have a ratio of 2 to 5. The last 2 terms, if you reduce negative 10 and negative 25 by 5s, that would also be a ratio of 2 to 5. So it looks like grouping is going to work on this. So for our first 2 terms, we can take out a y squared, and that's about it. So if we take out a y squared, that leaves us with 2y plus 5 inside the parentheses. For the next 2 terms, I can take out a negative 5, and if I do that, I get a positive 2y plus 5 in there. I also could have taken out just a plain old 5 and had a negative 2y and a minus 5 inside, but then I'd have to deal with those negatives inside anyway and take out a negative 1. So any way you do it, you're going to end up with this negative 5. So now I notice that both of these big terms have the common factor 2y plus 5. So I can take out that whole parentheses, and now I'll just take the things that are left in each term, y squared and minus 5, and put them in a parentheses next to it, and now this is fully factored. On this problem, we're trying to factor this expression with 4 terms. Since we have 4 terms, it's possible we could factor this by grouping. So let's look at the ratios of the first 2 and the last 2 coefficients. First 2, we have a ratio of 28 to 12. That reduces by 4 to a ratio of 7 to 3. Now, if you look at these next 2, negative 63, negative 27, you can reduce those by 9. That would also give you a 7 to 3 ratio. So definitely grouping is going to work on this one. Let's go ahead and do it now. So let's take out the biggest common factor we can for the first 2 terms. Again, these are both divisible by 4. 28 and 12 can be reduced by 4. So I'm going to take a 4 out of those. And I also can take out an a. So if I take out a 4a, we end up with 7b plus 3x for our stuff inside our parentheses. And now for the next 2 terms, it looks like I can take out for sure a negative 9, and that's about it. So if I take out negative 9, this first term is going to be 7b. Taking negative 9 out of negative 27 gives us positive 3x. So we end up with, again, 7b plus 3x. Since I have the same thing in both of those parentheses, I can take that whole parentheses out as a common factor. So 7b plus 3x is a common factor that I'm taking out of everything. And then all that's left over to go in a parentheses next to it is going to be this 4a minus 9. For this problem, we're trying to factor this expression. Since I have 4 terms, I'm going to see if I can do grouping for this one. Let me look at my ratios of my first 2 and my last 2 terms. So for the first 2, we have a 15 to 27 ratio. That reduces by 3s to be 5 over 9. If we look at the next 2, we have a 20 to 36 ratio. You can reduce those by 4 to be also 5 over 9. So since we have the same ratios, we can definitely use grouping here. Let me take a common factor out of the first 2 terms now. As we said before, we can reduce 15 and 27. They have the common factor 3. So we'll take out a 3. I'll also take out an a because both of those terms have an a. So taking out 3a, that leaves us with 5b minus 9x. And then for the next two terms, I can take out a negative 4, and it looks like that's it because the variables are different. So that leaves us also with a 5b, positive 5b, minus 9x if I take out a negative 4. Next, I can take the 5b minus 9x parentheses out of everything because that is a common factor. It's repeated in each of these two big terms. And now all that's left over is the 3a and the negative 4 to go in a parentheses next to it. For this problem, I'm trying to factor this expression. Since I have 4 terms, let me go ahead and try out grouping. Now, I see, just kind of checking beforehand the ratios here, the first two coefficients are 1 and 1, and the last two coefficients are also 1 and 1. That's the same ratio for the first two and the last two coefficients. So grouping may work on this, but we've got a bunch of different letters involved. So I think this is one where you just have to kind of dive in and see if it works when you try it. So for the first two terms, I have a common factor of a that I can take out. So that leaves me with a squared plus 1 inside. For the next two terms, it looks like we have a negative b that I can take out of both of those. That leaves me with a squared plus 1 if I take negative b out of both of those terms. And lo and behold, we have an a squared plus 1 in parentheses for both of these. So that means grouping is going to work. We can take out an a squared plus 1 as one big common factor. And then the leftovers, a minus b, when I divide both these terms by a squared plus 1, I can put a minus b in a parentheses next to it. On this problem, I'm trying to factor this expression. Since I've got 4 terms, I suspect grouping is a technique that I'll have to use. To make sure it'll actually work, let me look at the ratios of the first and the last two terms. The first two coefficients, we've got a 16 to 2 ratio, so that's an 8 to 1 ratio if you reduce that. Next two terms, we have a 56 to 7 ratio. That reduces by 8 to be, again, 8, or actually reduces by 7 to be 8 to 1. So it looks like the ratios are the same between the first two and the last two terms. So let me go ahead and try out grouping. For the first two terms, I can take out a 2 and a y. Taking out 2y leaves me with, this first term becomes 8x, and then this is going to be minus b. For the next two terms, I can take out a negative 7 and also an a, so negative 7a. That'll leave me with a positive 8x, and then this will be a minus b as well. Since I have 8x minus b repeated here, I can take that out as a common factor, and then the leftovers, 2y minus 7a, go in a parentheses next to it. And you can see that if you were to distribute this back out, you would have 8x minus b times 2y, this first term, and 8x minus b times negative 7a, this other term here.